Let's continue on our march towards all the problems. So let's look at problem 21. This one states find all the solutions of the equation 1 plus x divided by 2 factorial plus x squared divided by 4 factorial plus x cubed divided by 6 factorial plus 6 to the power 4 divided by 8 factorial plus dot 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 equals 0. And we're given a hint. Consider the cases x is greater than 0 and x is less than 0 separately. Alright, so let's dive into the solution. Let's using the hint. So let f of x denote the left side of the equation. So this whole thing is f of x of the given equation. So if x is greater than or equal to 0, then f of x is greater than 1 and there are no solutions of the equation. That's because if you put in x is 0 here, all these go to 0 and you're just left with a 1. And if you put in a number greater than 0, this all becomes just a positive number, and that just equals to 0. So in other words, we have 1 plus 0 or another positive number. 0 or, let's put number greater than 0. So in other words, this is going to be, well, greater than or equal to 1. And this is not equal to 0, so it's not a solution. Yeah, so not a solution. Alright, so now if we continue further, so basically, for x is greater than or equal to 0, it's not a solution. So now let's look at when x is less than 0. So note that, first note that f of negative x squared is equal to the Maclaurin series for cosine x. And we'll show that, and then we'll just need to find the zeros of cosine x. And note that, since we're converting this, or transforming the f of x into f of negative x squared, note that this has to be less than 0. So a negative x squared is less than 0 for, and this is for, well, all of these new transformed ones. So this one is our equivalent of our x. Equivalent, put 3 dots, just means that it needs to match up with this. So if we're looking at, for this f of x is less than 0, this negative x squared has to be less than 0. So this is for x is, well, for all x, it's actually for all x except not equal to 0. Because if you put in 0, then that equals to 0. So negative x, 0. But here if you put in if you put in x is equals to 10, so 10 squared is 100, is 100, then there's a negative sign, so it'll be less than 0. So for all x not equal to 0. So I'll just unbox that. So we have that. Now if we plug this inside, f of negative x squared inside here, then you could see that here, because this is x right there. Yeah, x, but we want this to the power of 2. This one, we want this to the power of 4, this to the power of 6, and so on. And that will match up with the Maclaurin series for cosine x, as I will go and look back at the table. So let's write this down first. So f of negative x squared is equal to 1 plus, and then the next setup is x becomes, well, that's x, that's an odd power, the negative stays. So negative x squared over 2 factorial. And then the next one is x squared, so negative becomes positive. Yeah, so negative squared even power becomes positive, so x to the 4 over 4 factorial. Then the next one is going to be minus, it's going to be x cubed. And then x cubed, it should be the negative x. Yeah, whoops, get this out of the bracket, like that. So negative x squared, all squared, this is going to be 6 factorial, because that's going to be over here. So this is x cubed, and the negative is going to be to the odd power, and that becomes still negative. The next one's going to be x8, so x to the 4, and then 4, x squared to the power of 4 is 8. And negative 1 to the power of 4 is positive. So this becomes like that, and then goes minus plus dot dot dot. And this equals to cosine of x. Now here I just quickly teleported to our table above. So here's our cosine x right here. And the radius of convergence is infinity. So r is infinity, converges for all values of x. So we have here this cosine x equals to 1 minus x squared divided by 2 factorial plus x power 4 minus divided by 4 factorial minus x6 divided by 6 factorial, and then plus x8 divided by 8 factorial, and so on. Alright, so here I quickly teleport it back here. So now that we have this, now we just need to find the zeros of this cosine x there. So the solutions of cosine x equals 0 for negative x squared is less than 0. So yeah, so remember, this x is a product of this transformed one. And the solutions manual even got it mixed up, I believe. So anyway, so we gotta get the solutions for cos x equals 0 for negative x squared is less than 0. So it matches up with our earlier one here. So basically when x is not equal to 0. That's the only way that this negative x squared term is less than 0. So this is given by, and let's just graph our cosine function. So recall the cosine looks something like this. It goes up and down and down, yeah, and like that, and keeps going on forever. Where this is at 0, this is 1, and then this is pi over 2 is at our 0. And then this distance right here is pi. And this distance, yeah, is pi. This is going to be 3 pi over 2. Or in other words, 2 pi over 2 plus pi over 2 is going to be 3 pi over 2. And then over here is negative pi over 2. And yeah, so it's negative pi over 2 is separated by pi. So in other words, and this is our, let's just put our x, and this is our y, and this is our cosine x. So in other words, this is separated by pi. Yeah, this is separated by pi, or you could even just go from here to here. It's a bit easier to see. Negative pi over 2 to pi. Yeah, so that's pi, like that. Yeah, so thus what we have is f of negative x squared equals to cosine x equals to 0 at x is equal to pi over 2, and then we'll just have a plus pi k. Yeah, and where k is any integer, actually. Yeah, so where k could be positive or negative. Doesn't need to be positive. The solution manual said positive because I think they got messed up. Where k is an integer. Yeah, it could be negative. For example, if it's -1, we'll have it over here. Alright, so yeah, so that is the solutions for cos x equals to 0 is that x equals pi over 2 plus pi times k, which k is any integer. And again, you can, yeah, this can go over here, you can go over here and add another, you can add, you can add as many number of pi's, and it will always be 0 because of the periodic nature of the cosine trig function. We'll make this a bit bigger. So that's for cosine x, or f of negative x squared. So the solutions for f of x equals 0 are, and this is in our case, well, because we solved this one here, f of negative x squared, this equals to 0 for x is equal to pi over 2 plus pi k. In other words, this throws it inside here. Yeah, I'll throw this inside here. This becomes, this is basically writing it as or. I'll just put an or. Yeah, or, and just throw that inside. Or f of negative, and then negative, put that all inside. Negative pi over 2 plus pi k all squared. Like this. You know, let's put that better. So f of, and then this bracket. Like this. Yeah, instead of this, we'll put this one here. The box brackets. This equals to 0, like this. Yeah, so when we put that inside here, so now this part right here is our equivalent value for that f of x we want. So that is, let's put it all together, that is f of x is equal to 0 for this, and now we'll have x is equal to negative, this whole thing here, negative pi over 2 plus pi k squared, like that. And k is any integer. Yeah, where k is an integer. Alright, so now that we have that, I just want to make a note. Note that I deviated from the solutions manual because it assumed that x is less than 0 even after it was, I'll put it was transformed to negative x squared. That is, they considered cos x equals 0 for for x is less than 0. And this does not necessarily always have to be the case, because if x is greater than 0, the transformation is still negative x squared is less than 0. And a simpler example is, for example, we have an example right here. For example, let's say we have fx is equal to x. Let's say fx equal to x. Fx equals to x. And this is less than 0 for x is less than 0. If we transform it, let's put it, but f of negative x is equal to negative x, and this is less than 0 for x is greater than 0. So in this case, we have it all on the opposite. So notice how this one here is, and not in the transformed case, not for x is less than 0. So that's the only way it can be less than 0 is if this x is positive. So yes, you have to consider what you're transforming, etc. So yeah, I believe I believe the solutions manual was not giving the proper solution.